So how do I know if a change resulting from an A/B test is real, if it's actually a real result of what I changed, or if it's just random variation? Well, there are a couple of statistical tools at our disposal called the t-statistic and the p-value, so let's learn more about what those are and how they can help you determine whether an experiment is good or not. So as I said in our previous lecture, variance is your enemy when you're running an A/B test. So how do we account for that? Well, there are some statistical tools at our disposal called the t-test, the t-statistic more specifically, and the p-value, which allow us to quantify the effect of variance on our results and make a decision that takes that variance into account. So the point is to figure out if a result is real or not. Was this just a result of random variance that's inherent in the data itself? Or are we seeing an actual statistically significant change in behavior between our control group and our test group? T-tests and p-values are a way to compute that. And remember too, again, statistically significant doesn't really have a specific meaning. At the end of the day, it has to be a judgment call. You have to pick some probability value that you're going to accept of a result being real or not. But there's always going to be a chance that it's still a result of random variation. And you have to make sure your stakeholders understand that. So let's start with the t-statistic, also known as the t-test. It's basically a measure of the difference in behavior between these two sets, between your control and treatment group, expressed in units of standard error. So it is based on standard error, which accounts for the variance inherent in the data itself. So by normalizing everything by that standard error, we get some measure of the change in behavior between these two groups that takes that variance into account. So the way to interpret a t-statistic is that a high t-value means there's probably a real difference between these two sets, whereas a low t-value means not so much. So you have to decide, what's a threshold that you're willing to accept. And the sign of the t-statistic will tell you if it's a positive or a negative change. So if you're comparing your control to your treatment group and you end up with a negative t-statistic, that implies that this is a bad change if that absolute value of that t-statistic is large. How large is large? Well, that's debatable. We'll look at some examples shortly. Now, this does assume that you have a normal distribution of behavior. And when we're talking about things like the amount people spend on a website, that's usually a decent assumption. There does tend to be a normal distribution of how much people spend. However, there are more refined versions of t-statistic that you might want to look at for other specific situations. For example, there's something called Fisher's exact test when you're talking about click-through rates, the e-test when you're talking about transactions per user, like how many web pages do they see, and the chi-square test, which is often relevant for when you're looking at order quantities. So sometimes you'll want to look at all of these statistics for a given experiment and choose the one that actually fits what you're trying to do the best. Now, it's a lot easier to talk about p-values than t-statistics because you don't have to think about how many standard deviations are we talking about and what does the actual value mean. The p-value is a little bit more easy for people to understand, which makes it for a better tool for you to communicate the results of an experiment to the stakeholders in your business. So the p-value is basically the probability that this experiment satisfies the null hypothesis. That is the probability that there is no real difference between the control and treatment's behavior. So a low p-value means there's a low probability of it having no effect. Kind of a double negative going on there, so it's a little bit counterintuitive. But at the end of the day, you just have to understand that a low p-value means that there's a high probability that your change had a real effect. So what you want to see are a high t-statistic and a low p-value, and that will imply a significant result. Now, before you start your experiment, you need to decide what your threshold for success is going to be. Decide that with the people in charge of the business. So what p-value are you willing to accept as a measure of success? Is it 1%? Is it 5%? And again, this is basically the likelihood that there is no real effect. That's just a result of random variance. It's just a judgment call at the end of the day. A lot of times people use 1%, sometimes they use 5% if they're feeling a little bit more risky, but there's always going to be that chance that your result was just spurious random data that came in. But you can choose the probability that you're willing to accept as being likely enough that this is a real effect that's worth rolling out into production. So when your experiment is over, and we'll talk about when you declare an experiment to be over, you want to measure your p-value. If it's less than the threshold you decide upon, then you can reject the null hypothesis and you can say, well, there's a high likelihood that this change produced a real positive or negative result. If it is a positive result, then you can roll that change out to the entire site, and it is no longer an experiment. It is part of your website that will hopefully make you more and more money as time goes on. And if it's a negative result, you want to get rid of it before it costs you any more money. So remember, there's a real cost to running an A/B test when your experiment has a negative result. So you don't want to run it for too long because there's a chance you could be losing money. And this is why you want to monitor the results of an experiment on a daily basis. So if there are early indications that a change is making a horrible impact to the website, maybe there's a bug in it or something that's horrible, you can pull the plug on it prematurely if necessary and limit the damage. So let's go to an actual example and see how you might measure t-statistics and p-values using Python up next. So that's the t-test, the t-statistic and the p-value, useful tools for determining whether a result is actually real or a result of random variation. So next, let's dive into some real examples and get our hands dirty with some Python code and compute these things.